Hello everyone. Welcome to this session on descriptive statistics, sampling and estimation, probability distribution for descriptive analysis. In this lecture, we will understand how statistics help us summarize data, estimate population, values from samples, and analyze uncertainty using probability distributions. We will also learn the important formulas and practical applications. Let us begin with descriptive statistics. Descriptive statistics is a branch of statistics used to summarize, organize, and describe data. Instead of analyzing every individual data value separately, descriptive statistics help us present data in a meaningful way. It mainly focuses on measure of central tendency, measure of dispersion, data distribution, and shape. These techniques are widely used in business analytics, healthcare, research, economics, and data science. Measures of central tendency help us to identify the center or typical value of a dataset. The three important measures are mean, median, and mode. Mean, the formula for mean is mean equals sum of observations divided by total number of observations. Median is the middle value of arranged data in ascending or descending order. It means the shorter data has a middle value, and that middle value is called a median. Mode is the value that occurs most frequently. Let us see an example. Consider the data set 2, 4, 4, 6, 8. Mean equals the sum of all the data 2 plus 4 plus 4 plus 6 plus 8, which is 24, divided by 5, which is equal to 4.8. Median is the center value. Since this data set is already in ascending order, it is already sorted. So the middle value is taken as median. So the median is 4. Mode is also 4 because it appears most frequently. Now let's learn measure of dispersion, which tells us how spread out the data values are. The first measure is range. Range equals maximum value minus minimum value. For example, if you're writing an example for 100 marks, the lowest mark is 0 and the highest mark that you can score is 100. Hence, the range is from 0 to 100, which means the range is equal to 100 minus 0. Variance. Variance measures the average squared deviation from the mean. The population variance formula is sigma squared equals summation of x bar x minus mu the whole squared divided by n. Sample variance formula is s squared equals summation of x minus x bar the whole squared divided by n minus 1. Standard deviation is simply the square root of variance. It means sigma equals the square root of variance. Higher standard deviation indicates greater variability in dataset. That is, how far a data is varied from the central value or the measured value that you have taken. For example, if you have a data set for the class details or marks collected for a class, then the center value is the pass value. Consider the center value as pass value 50. Then how far the data that you have collected has varied or deviated from the 50 represents the variance. And the square root of that variance is called the standard deviation. Now let us move to sampling concept. Population refers to the entire group that we want to study. For example, all students in a university, all customers of a bank, all customers of a department store, etc. A sample is a smaller subset selected from that population. Since studying the entire population may be costly and time consuming, we often use samples. For example, the entire population, all students of a university may be considered as a population. Students of particular department are considered as samples. Students of particular year may be considered as a sample. Student of particular category may be considered as a sample. Common sampling methods include random sampling, stratified sampling, systematic sampling, cluster sampling. There are two types of sampling, probability sampling and non-probability sampling. If the data are considered, if every selected data are given equal importance, then it is called a probability sampling. Non-probability means the data are not given equal chance to be selected. Sampling helps to reduce cost, time, effort while still providing us useful insights. After selecting a sample, the next step is estimation. Estimation means using sample information to predict population characteristics. There are two major types. Point estimation that provides a single value estimate. For example, sample mean is used to estimate population means. Interval estimation provides a range of values within which the parameter is likely to lie. Usually, the sample mean is represented by x bar and is used to estimate population mean represented by mu. Confidence level. An important concept in estimation is the confidence level. Confidence level gives a likely range for the true population parameter. Confidence level equals x bar plus or minus z multiplied by sigma divided by square root of n, where x bar is the sample mean, z is the confidence coefficient, sigma is the population standard deviation, n is the sample size. For a 95% confidence level, the value is 1.96. This means we are reasonably confident that the total population or true population mean lies within the calculated interval. Now let us learn or understand what is probability distribution. A probability distribution shows how probabilities are assigned to different possible outcomes. There are two main types, discrete distribution and continuous distribution. It deals with countable values. Discrete distribution deals with countable values. Continuous distribution deals with measurable values. Probability distribution are extremely useful in descriptive analysis and prediction. Binomial distribution. One important discrete distribution is binomial distribution. It is used when experiments satisfy these conditions. Fixed number of trials, independent trials, and two outcomes, either success or failure. Here the formula is P of x equals x is equal to NCx multiplied by P raised to x multiplied by 1 minus P raised to n minus x. For example, finding the probability of getting exactly 3 success in 5 attempts. Now let us study the normal distribution. It is one of the most important continuous probability distribution. It is represented by a bell-shaped curve. The key property is mean equals median equals mode. For a normal distribution, a mean has to be equal to median, which is equal to mode. If it is lesser, then it is negatively skewed. If it is greater, then it is positively skewed. And look at the formula here. Normal distribution is widely used in quality control, finance, research, machine learning, predictive analytics, etc. Here, what you're seeing is the normal distribution curve. Application. Let us look at the practical applications. These concepts are used for customer behavior analysis, survey data analysis, forecasting future trends, risk assessment, performance evaluation, business decision. In real world analytics, descriptive statistics and probability distribution support data driven decisions. Now, to conclude, descriptive statistics help summarize and understand data. Sampling and estimation allow us to make conclusions about populations using samples. Probability distribution helps model uncertainty and analyze outcomes. Together, these concepts form a strong foundation for statistics, business analytics, and data science. Thank you for watching.